Right, okay. I have 15 minutes, so I want to get started and give you as much information as I can. Now, the idea of this presentation is around a project which I actually started probably about 18 months ago now. And what I am is, I'm a Java Technology Evangelist, which means I like to play with Java. And I also am what we call in the UK a petrol head, because I really like cars and tinkering with cars and all things mechanical. So I tried to combine my two favourite passions into one project, which is how I came up with the idea of my Carputer, as I've called it. And so this is really kind of like a 15-minute update, if you like, on what I've been doing with that project. So, as an Oracle employee, the first thing I always have to put up is the safe harbor statement, which says that we're not committing to deliver any particular product on a particular date. I think I am pretty safe with my Carputer that we are not going to be delivering this as a product from Oracle anytime soon. So, let's move on from that. Now, here is my first car, a Mini 1000. In fact, it was the Mini Clubman 1000. Anybody remember the Mini, the original Mini? Anybody have an original Mini? Oh, okay. Well, this was it was a great car. It was very simple in terms of its design, which was good because I had to fix it most of the time. From a technology point of view, there were absolutely no electronics in this car whatsoever. Well, actually, that's not strictly speaking true because there was a radio until it got stolen. And then there really were no electronics in the car at all. Everything was electromechanical. So I had points. Now, anybody remember points in a car and having the feeler gauge? Good, at least one person, two people, good. So it was all mechanical, electromechanical, points distributor, it had manual choke, all these kind of complicated things, drum brakes, a dynamo. And then for luxury items, it had lights, a horn, it had wipers that sometimes worked, it had a fan that worked occasionally, and it had an ignition switch. But if you look at the wiring diagram for this car, which I still have the original service manual for it, it's actually quite complicated. There's a lot of wiring that goes around the car. Let's skip forward to 2011. This is my current car, which is an Audi S3. This has lots of electronics in it. Pretty much everything now is controlled electronically. There's computers involved and systems that make sure that everything works correctly. From the engine perspective, it has an engine control unit. And this particular model, you can't do this anymore, but previous models, I've had a couple of these in the past, you can actually remap the engine control unit just by downloading a new set of values, and you can change the amount of power that's generated by the car. Something that kind of like is quite amazing to me, that you can simply change the programming and then change how much power you get out of it. All of it's like fuel injection, it's electronic timing. The throttle is fly-by-wire, so there's no actual physical connection between the throttle when you press it and the engine. It's all electronic. There's a sensor that detects what position it's at and then feeds that to the computer that tells how much petrol to inject and so on. It has a better braking system. It's got anti-lock brakes. Pretty much every car you can get nowadays has anti-lock brakes. Also has electronic stability programs. The idea is if you go around a corner too fast, there's an accelerometer. It measures the speed of the wheels using the ABS sensors and then determines whether you're actually out of control. If you are, it tries to bring you back under control by applying the brakes on one or more wheels to restore the stability of the car. My current car even has this amazingly named magnetorheological suspension, and that's a set of shock absorbers that have a kind of magnetic fluid in them rather than just normal oil type fluid. And then by applying electric field around the shock absorber, you can change the viscosity of the liquid and how hard the suspension is. There's a button in the car which has two settings. There's comfort mode and then there's sport mode, which would also be called uncomfortable mode. Satellite navigation, auto-sensing wipers and lights and all sorts of things like that. So what I decided to do, as I say, was to build a Carputer. And my original idea was to gather more information from the car and potentially other sensors, and then display it on, as you can see, there's a little box here, as you're driving along. So rather than just having the dials which show you what speed you're doing, what speed the engine is doing, how hot the engine is, and how much fuel you've got left, the idea was to show all sorts of other sort of interesting values as you're driving along. So that was kind of the Mark I version, was to build a system that I could put in the car and display values as I was driving along. That worked quite nicely, and I managed to do that reasonably well. And I came up with the idea of taking it a step further. So this is the Java Carputer Mark II. Using the same box, so still got a display, still various sensors, but adding more information to it in different ways. And really the emphasis was shifting away from displaying data as you're driving to recording all of the data so that we could play it back later and therefore do analysis of driving style. Actually has real applications in terms of things like driver training, insurance purposes, fleet management, so things like that. And this is the structure or the architecture that I came up with. So in the middle, we've got the box that I've got sitting here at the front, and that has a Raspberry Pi inside it. And for the version 2, I actually upgraded it to a Model B+, because it had more USB connectors and better power management of the USB, so that seemed to be like a good idea. And then various different sensors and things connected around that. Started off with, on the top left-hand side, there's the OBD2 connector. And there's a little box that you can buy from eBay, which is very nice, and it plugs into the service port of your car underneath the dashboard. And then this particular one operates as a little Wi-Fi hotspot. And that way you can communicate with the car, you can gather data from that using a particular protocol that's available on every car. So that was good. Connected that using Wi-Fi. I also had an accelerometer that I'd used in the past, and so I had that connected to the Raspberry Pi. That way I could measure the acceleration forces, the G-forces, as you're going around a corner, as you're accelerating, as you're braking, and also as you go over bumps, you can see the acceleration in different directions. One thing I thought would be nice would be to monitor my heart rate as I was driving along, so you could see where the more exciting parts of the road are and how different things affect you as you're driving along. So I had a heart rate monitor board, USB connection, plugged that in, wrote some Java code, and then for the system when I was using it, I would wear a heart rate monitor, you know, the kind of thing you wear in the gym, and have that. I also thought it'd be really nice to have video from the car. So it's nice to have all the different values from the different sensors, but having video where you could see what was happening as you were driving along would be interesting to map that to the values that you have in the different displays. And so I bought one of these in-car cameras, and these are becoming a lot more common nowadays for insurance purposes. A lot of people want to be able to record what's happening, so in the event that they have an accident, there's proof of who was actually responsible. Ideally not you. GPS sensor, I thought it would be useful to gather information about position, potentially, and also speed and direction. Although the car has a GPS system for the satellite navigation system, I couldn't really kind of just tap into the data from that. So I added another sensor. That one was connected via a serial port, so I used the UART on the Raspberry Pi and connected that. I had a great idea about having tyre pressure monitoring. And again, on eBay, I bought these sensors that you could screw onto the valve caps, and it would measure the pressure of the tyres. So those actually send signals using basically radio on the, 433 megahertz frequency, which is one of these open frequencies. Same as that you use for remote controls and the thermostat in your house and things like that. I did spend some time working on that and trying to decode the signals that were coming from the individual sensors, but I haven't actually made a lot of progress with that, so there's not really any data that I'm extracting from that. To be honest, It's a little bit different to Formula One. Hopefully the tyre pressures on your car don't really change much as you're driving along, so it probably wouldn't be that interesting as a set of data anyway. Then I had a couple of other sensors that I wanted to connect, and to make life easier for that kind of thing, I actually used another Raspberry Pi. So I had two Raspberry Pis networked, and then I could connect some other sensors to the second Raspberry Pi. One of those was being able to get to the CAN bus, and this is the way that wiring is done in cars now. It uses a bus architecture to give you all the different information, and you can see all the switches and sensors and things like that. That's something I'm still working on, so there's a bit of work going on there. And I also wanted to be able to measure temperature of different things in the car, so I had some thermal sensors that I connected so I could actually measure the temperature of the brake disc and the tyres as well. If you come to I'm doing a BOF at 7 o'clock this evening, I'll be talking about a lot more of these things in a lot more detail about how the different bits work and so on. So this is the setup in my car. You can see on the left-hand side, that's really the box as I finished it. So it's all kind of like quite densely packed in there, and some very nice wiring there. Also, you can see that, as with every good software project, it does involve woodwork. So that was good. Very important thing for me. And there it is installed in the car, so you can see the different bits in action. So really, that's all I wanted to say. I'm just going to give you a couple of demos of this in action. So there was one bit I didn't talk about, which I didn't have time to put a slide together for it. But let's see, where are we? If I go, find this, where are you? And then this. So I also built a heads-up display because I thought this would be interesting. So you can just see there. It turns out it's actually quite difficult to build a heads-up display, but the idea is that you can see that I'm projecting the speed and the speed limit. Don't be alarmed that I'm actually going over the speed limit. What I didn't discover until I actually set the system up was that the speed I was getting from the car is in kilometers an hour, and the speed limit's in miles an hour. So I was still being, very good. And I also put a tachometer in the bottom that you can see there. So that was one thing I wanted to show you. And then the other thing was, having collected a lot of data, I thought it would be interesting to write an application that would allow me to play back the data. So this is, actually, is that the right one? Yes, it is. Good. So this is a JavaFX application that I wrote, which takes the data that was recorded as I was driving around and the video information that was recorded on the video camera, and then plays it back. So what I've got here, like I say, is a sort of display. There's different parts to this. So there's speed data, so we can compare the speed that's coming directly from the car and the GPS sensor. There's also the GPS data in terms of position and altitude. There's various different temperature values that we can get for the air coming in, the coolant, exhaust, tyres and brakes. GPS data overlaid on a map. This is not quite working at the moment, so I haven't actually got it to update the information there. Heart rate, so I can see what's actually happening with my heart rate. A couple of dials to show engine load and fuel pressure. The video in the middle here, again, the tachometer along the top in Formula One style, and also Formula One style down here, which shows, eventually, I haven't got this bit working either, which gear you're in, when you're braking, the amount of throttle you're using, and the amount of engine speed. So if I play the video, what happens is obviously it'll start off playing the video, and you can see as we move along that various things will change. So we've got the engine load changing, the fuel pressure, heart rate. So it stays fairly stable, actually. And then, as I say, down here you can see values such as the throttle position and the engine RPM, which kind of ties in with that. And if I kind of skip forward, you can see various different things change. And it's quite interesting to see the comparison between speed data from the car and the GPS. Turns out the car is actually pretty accurate compared to the GPS. And then just one last thing I'll show you, which is the idea of graphing data. So I can actually select, let's say, take throttle position, because that's quite interesting. And then if I graph that, that shows you the complete set of data that I took for the throttle position. So you can see I was accelerating quite hard in places. And then finally, we can just show one more thing, which is the, where is it? Driver heart rate, there we go. So this is quite interesting because, as I say, heart rate was fairly stable, but you can see that there was one point where something got a bit exciting there. My heart rate went up. I mean, there's also one point where things got very calm. So the heart rate dipped there. I don't quite know what happened. But so that's about it, actually. I've just about run out of time. As I say, there is going to be a BOF later on today at 7 o'clock where I will talk a lot more about the way the individual sensors and so on work and a lot of the other background to this. So with that, thank you very much.